All right, so last class, someone, and I wish I could remember who, but someone actually led us directly into this because we were talking about some of those functions where we said, okay, cosine and sine only go from like 1 to -1. And because of that, when we had answers outside of that, we just got rid of them, okay? And then someone really nicely asked me and set me up for this by saying, what if it's another number between -1 and 1, but it's not something in our chart? Like, let's just say it was like 0.25. What if cosine equals 0.25? Well, according to our graph, can cosine equal 0.25 at some point? Sure. Do we have 0.25 in our chart? No. That doesn't mean we can't find answers. It just means we need our calculator to find the answers, okay? So instead of getting a nice pi over something radian, we're going to get a decimal radian as our answer, okay? Now, just like every other one, when we were solving things like cosine equals 1/2, we found one answer out of our chart, and then we used reference angles to find a second answer, right? Your calculator is going to give you one answer for these, and then you're still going to have to use reference angles to find the other answer. So part of what we're going to work on this is doing reference angles in decimals, which feels a little bit funny, but we'll be drawing a lot of pictures for that, because otherwise we just kind of get lost. The other thing we do need to remember for this, and it is helpful to us, is when we did on day 1, we talked about inverse sine, inverse cosine, and inverse tangent, yes? We talked about that they had programming in our calculators, and we only gave answers out of certain quadrants. Do we remember what those quadrants were? Sine was which quadrants? 1 and 4. Cosine was 1 and 2. And tangent was 1 and 4. I bring this back up because when we type these into our calculators to get an answer, it is sometimes helpful to know which of those quadrants you're getting an answer out of. So if the sine value is positive, you're going to get an answer from quadrant 1. If the sine value is negative, you're going to get an answer from quadrant 4. Cosine is positive, will give you an answer in 1. Cosine is negative, will give you an answer in quadrant 2. Tangent is positive, will be 1. Tangent is negative, will be 4. Okay? Now, I told the other class this as well. These are not successful questions in general if you do not draw yourself pictures for them. Having the visual of what this looks like and reference angles with this is very, very much helpful to you. I would not advise doing this without a calculator. Or calculator you need, I mean a picture. Okay? All right, so here's where we're at on this. If there's any solving to be done on the actual equations over here, we will do that solving first. Just like any other one, if you need to add 1, subtract 1, divide by 2, whatever it needs to be, we'll do that first. Then we are going to set ourselves up for where we have answers based off of our plus minus chart, and then deal with our calculator. I did cross out, and if you'd like to also cross out here, we are not going to be doing anything in degrees. It is not helpful to us. It is not helpful to us in calculus, and so we're just changing to make everything in terms of radians, no degrees. Okay? All right, so in question 1, I do not have any solving to do first because sine is already by itself. All I need to do is figure out the angle at which we have this sine value. So before I ever touch my calculator, when the sine, the cosine, the tangent is by itself, I pause and ask myself, is this a positive or a negative number? Negative. Okay, so let's draw ourselves our first picture. In which 2 quadrants is sine negative? 4 and 1. No, 3. Not 1. Okay, are we all okay with sine being negative in quadrants 3 and 4? This is just based off of our all students take calculus. Yes? All right. In order to get our very first answer, what are we going to type into our calculator? How do I find an angle? Inverse. That's where we use our inverse button in our calculator, yes? So you don't need to write it down, but what we're going to type into our calculator is the inverse sine of whatever this number is, okay? So we're going to type that in. Before we type that in, we need to make sure that you are in what mode? Radian. Everything is in radians. Okay. So inverse sine of negative 0.82. What does your calculator give you back out? we're going to round to 4 decimal places. 0.9614. Okay. Now, this is where I refer back to our rules for inverse sine, inverse cosine, inverse tangent. Which of those 2 answers is that? Quadrant 3 or quadrant 4? That is 4. How do I know that? Come back over here. Where did we say we get answers from inverse sine? 1 or 4. Is 1 even an answer for this one? No. So your calculator is giving you an answer out of quadrant 4 because sine is a negative value. And that's what your calculator does. When sine is a negative value, you get an answer in quadrant 4. That is my first answer right there. That is this amount of rotation backwards. Yes? This is also known as your reference angle, although we don't use the negative for the reference angle. So if that is the reference angle there, that is also the reference angle over here. So that 0.9614 can be used as a reference angle right there. So I need to find a second answer using that reference angle. So if you remember reference angles a little bit from chapter 6, those were, if that is pi, what am I going to do with pi in that reference angle to find that answer? Add them, because I'm going forwards in amount of rotation. So if I take in my calculator pi plus 0.9614, not the negative. Why am I not using the negative? Reference angles are never negative. So I use that amount of rotation. What do we get as our second answer? 4.1030. Okay, that is my second answer. Now, if you do not like this negative angle, you may also choose to say 2 pi minus that and get an answer in quadrant 4. I'm not sure why you'd want to do more work. Like whatever your calculator gives you as your first answer is great, but totally up to you how you handle that. Okay? You may give a negative answer if it is in quadrant 4. That's okay. We do not give negative answers in any other quadrants. Okay? So what we are just doing is practicing finding those 2 answers. Your calculator will give you one. You will need to find the other. And that's where we're going today. So in question 2, I have one thing I have to do before I can type anything into my calculator. What is it? Divide by 5. So if I divide by 5, I get cotangent is equal to 12 over 5. So now let's make that 2 things I have to do before I type it in my calculator. Do I have an inverse cotangent button? I do not. Therefore, what must I switch this into? Tangent. If cotangent is that, tangent is 5 over 12. Now, before I ever type it in my calculator, I draw myself a picture. Tangent is what kind of number? Positive. Yes? Where is tangent positive? What quadrants? 1 and 3. Okay? Tangent, and all students take calculus, is positive in 1 and 3. So now I'm prepared to be able to label one of my answers. What am I going to type into my calculator? Inverse tangent of 5 over 12. So I type in inverse tangent of 5 over 12. I get out of my calculator, what decimal? 0.3948. Which of my 2 answers is that? Okay, 2 reasons I know this is first quadrant. Back over here. Inverse tangent in my calculator gives me answers in quadrants 1 and 4. 4 is not even a possibility for this question. Only 1. Secondly, do you remember way back when we learned like what a radian was? We said, oh, pi over 2 is about 1.57. Pi is about 3.14. 2 pi is about 6.28. And 3 pi over 2 is about, I never remember this one, 4 point something. I really honestly don't remember. But it's about 4.71. Those decimals can kind of help you place where this one is as well. This is smaller than 1.57. Therefore, it must be this answer. Therefore, it is also my reference angle. If it is also my reference angle, I may use it over here to find my second answer. What am I going to do to find my second answer? I'm going to take pi, and I'm going to add that reference angle. 0.3948. And I'm going to get 3.5364-ish. All right, so on question 3, what do I need to start off by doing? Minus 9 and divide by 3. So I have cosine equals what number? Negative 2 over 3. All right, so here's where we pause and we say to ourselves, cosine is positive or negative? Negative. What quadrants are we in? 2 and 3. All right, next step is type in what? Inverse cosine. Now here is where sometimes we have some weird stuff going on. If I type in inverse cosine of negative 2 over 3, what do I get as the first answer? 2.3005. All right. This is the first one where that first answer does not give me the reference angle. Why is this not the reference angle?
Because that's from like
that. That's what 2.3005 is. It's that whole distance. Reference angles have to be less than 90 degrees, okay? So we have a couple options here. We know about reference angles, so I often talk about finding them. You could find that reference angle right there by taking pi and subtracting that answer. That will not give you your second answer, but it will give you the reference angle. There is also a different way of doing it. If you're like the visual person that understands that the distances are the same, that 2.3005 forward is the same amount as this amount of rotation backwards. So I could take 2.3005 and subtract it from what? 2 pi to find that answer. Some people always like using reference angles because it's something familiar to us. Other people are like, well, that's one extra step, because if I have to find the reference angle by subtracting from pi, then I have to take the reference angle and put it down here and add it to pi to find the other answer. Either way, you get the same answer. It's just one extra step. Whichever way feels more comfortable to you. This is why I draw the pictures, because then I don't have to think about forwards, backwards in my head. I can just see, oh, look, that distance is the same forwards as it is backwards from 2 pi. So I say to myself, 2 pi minus that answer gives me my second answer of 3.9827. Okay? Now, before we leave this for today, I would like you to do one of these on your own. Okay? Same process. Let us at least try question, I think we'll do like at least 2 of these, but try question 4 and we'll see how we're doing. And I get, my first answer here is 1.7722. That is this amount of rotations forward. So I have 2 options. I can take that same amount of rotation backwards from 2 pi to get my second answer, or I can subtract that from pi to find the reference angle and add the reference angle to pi to go forward from there. Either way will give me the same answer. As long as you understand what you're doing, I'm good. 2 pi minus that answer for me gives me my second answer is 4.5110. Now, I will say in the back of my head, I don't like memorize a ton of decimals, but I do have in the back of my head that this one is about 1.57, this one's about 3.14, this one's about 4.71, and this one is about 6.28, purely because if you just kind of go like do one minus or plus wrong, which is really easy to do with the decimals, you're going to get an answer that's not in the right quadrant, and that's like my first tell that I've done something wrong. Like this one, I might be a little bit off about finding it, but I do know it's between 3.14 and 4.71. Whereas if you add or subtract the wrong thing, it'll probably throw you into the wrong quadrant. And then you immediately know you're wrong if you have a little bit of like number sense on that one. Okay? Shall we do one more? Maybe? Sure. All right. Let's get started on 5 together, and then you can finish finding the answers yourself. If I'm solving for cosecant, what am I going to do?
Add them to the other side, subtract 7.
Yeah, I'm going to add the cosecant to the other side and subtract 7. So that's giving me cosecant is equal to -4. No, I never solve with a cosecant. I always switch it to a sine. So if cosecant is equal to -4, what is sine equal to? -1/4. So before I ever type anything in my calculator, here is where I draw my picture. Where is sine negative? 3 and 4. All right, see if you can find those two answers, 3 and 4. So we know sine is negative in quadrants 3 and 4. Our calculator gives out point -2527. That is the reference angle as a positive. So we use the positive 0.2527 right there to go forwards from pi and add that. Reference angles are never negative. So the negative on our first answer, we drop that when we use the reference angle because we are rotating forwards rather than backwards. So if I take pi and I add to it 0.2527, I get as a second answer, not what I just got out of my calculator because I did not put plus, 3.3943. So I do not want to use the negative because that will take me backwards into quadrant 2. So if it's less than 3.14, you've added the negative rather than the positive. All right, one last one, then we're done. Okay, try question 6 the whole way through. Let's finish this real quick. If I type in my inverse cosine of 3/5, were we all okay with inverse cosine of 3/5? Is that what we got? Yeah? My first answer is 0.9273. That is also my reference angle. So theta, first one, 0.9273. Second one is I use that same reference angle, and what am I going to subtract it from? What am I going to subtract that reference angle from? 2 pi. So 2 pi minus 0.9273 gives me second answer of 5.3559-ish. Good? Okay. Real quick, last thing. I want to tell you what homework questions you are going to do. Okay? All right, so on your 8.7 homework, we are doing, because there's kind of 2 different sets and the numbering starts over again. So on the first 2 pages, we are doing 1, 3, 5, 7, 10, and 15. Okay? And then on the second set of 2 pages, we are doing 6, 8, and 14 through 18. But make a note on that second set of pages, change the directions so that they are all in radians, 0 to 2 pi. Don't do anything in degrees. The first page says degrees, but don't do it that way.